This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with Gen AI. Okay, so guys, so far what we have seen, we have gone through with these particular steps. Let me pick these particular steps and paste it over here. Big Data with Gen AI. Okay, so what are the steps that we have covered so far? So we were having a file that is names.txt. Okay, it is having certain names in this particular file. Names are there. Okay, like Emma, Olivia. Okay, so certain names are there, and what we have done, we read this particular file and converted this particular file into words. Okay, so the file is having names like Emma, okay, Olivia. Okay, it is having the names in this particular way. Okay, so these are, this is a text file, and the words, these particular names are separated by the new line character over here. Like say new line character is there if we are talking about this particular file. So we have splitted it, this particular file, and we have converted it into words. So split lines and then we got the words. Okay, so we have splitted this particular file into words. Okay, and then words are then further splitted into letters, and based upon the letters we found the combination. Basically this particular model, diagram language model, what it will do, if we are providing say a, it is providing say my name is Ashok. Okay, and over here if I'm providing a, the model will be able to predict say s is the next character. If I'm providing s, then the model will be able to predict h, and if I'm providing h, so the model will be able to predict say o. If I'm providing o, so the model will be able to predict say k. Okay, this is the way like how this particular model is working. So if k, that is nothing but the and character ending. Okay, and a, if like start is there, so after start a will come. Okay, so start a will come. So if I'm starting and I'm like if I'm starting and not providing anything, so the most probably it is providing me a with respect to this particular you can say data with respect to this particular name. So 1 2 3 4 5 and 6 combinations are there with respect to this particular name. A, then S, if S is provided, then H, if H is provided, then O, if O is provided, then K, if K is provided, that is most likely to be the ending character. So this is the diagram language model. Based upon the given letter or character, I'm going to predict the next one. So what I need to do, I need to have these particular combinations. So I try to find out the combination, and how I have found the combination, just by splitting these particular letters into the list, and one list is started with 0th index and another is started with the one first index. So based upon that I'm able to get the combinations. Then if I need to I'm having say 32,000 names. So what is the priority, what is the probability of a, what is the probability of s after a, what is the probability of h after s? So how I will be able to calculate this if I'm having all the combination with respect to all the words? Okay, then I will find out the unique combination, and the combination which is more, then I will say this is the most likely character. Okay, say I have taken this particular example, like okay, like em is there 1000 times. I found out the combination like M after E is coming 1000 time, A after M coming 20,000 time in the given data. So for me, A is the most likely character after M. A is most likely character after M. That's what I have done. That's what I have calculated with the help of this particular code. Okay. So the combination, we found the combination, then we count the sum of each combination, then we have created a tensor. Okay, we have created a tensor and we move this particular count into that particular tensor. And why 28 cross 28 tensor was created? Because in English language we are having 26 letters and we have added starting and ending character, start and end, starting and ending character, this we have added. So because of that 26 letters plus starting and ending character, so we are having 28 characters in total. So the tensor will be 28 cross 28. Why 28 cross 28? Because it will be looking like this. A I have shared this in the previous session as well. Let me show you. Okay, so just have a look over here. So A, B, C, D, E up to 28 will be there. Starting and ending character will be there. And in the same fashion, A, B, C, D, like horizontally and vertically, I will be having this. And with the help of this, what I am able to see, like dot is having zero count after, like dot will not come after dot. Okay, because this is the starting and ending. Or you can take it in this way, uh, with respect to the starting and ending, we can have this particular example. Okay, okay, so over here, say A is having zero count, A after A after B. Okay, like after, if I'm giving A, then A will come 556 times. If I'm giving A, B is coming 542 times. If I'm providing A, C is coming 470 times. So based upon this, what I have done, I have calculated the percentage of each and every occurring, and the number which is the letter which is having the highest percentage, at that moment what I can say, it is the most likely letter which can come after A. So over here, this 5432 is the highest count and I think it is for N. So N is the most likely letter that will come after A. So with the help of this, I'm able to get, like, this is the stuff. So this we have done mathematically. Okay, the percentage we have calculated, like if we divide each element by some of the all elements, then I will be able to get the percentage. So that's what I have done over here. Okay, uh, okay, just have a look over here what I have done. So if I have the first row, and if I have divided each element by sum of all the elements, then I got the percentage of each and every element. Okay, so based upon this, I will be able to say that this is the most likely character. Inside the deep learning, the PyTorch library, we are having one function, multinomial. Multinomial function is there. What this particular function is doing, if I'm providing an input and if I want to have certain samples from that given input, so I will be able to get the most likely output. So over here what we found, like if I want to have one sample from given P, so it was randomly giving a particular number. Like sometimes it was giving 14, sometimes it was giving 25, sometimes it was giving 0. Yesterday we have seen this. So this is because of multinomial function which is there inside the PyTorch. So we have utilized this particular function in order to find out the most likely character, most likely letter. That is perfectly fine, but we want to fix the outcome. uh, like for a given input, the output will not be changed. For a given input, the output must not be changed. So generator is a functionality, and we can provide a seed over here, and with a unique seed, with a particular seed for a given input, the output will not be changed. So the seed is having this particular functionality. Like if over here, if I'm not fixing the seed, so for same input it will be having different output. For same input it will provide me the different output. But generator, this particular seed, what it will do, for the same input the output will not be changed. So this is the functionality of the seed. So based upon this, what I have done, I have calculated the words. Okay, I have calculated the names. I try to find out the names. Like until unless like this particular I of x, until unless the true condition is there, the p, that is the probability, you can say, you can take it in this particular way, probability of one row. Okay, I have converted it to float, the same stuff what it is mentioned over here. Like I have taken one row. Okay, so based upon the value of ix, say it is, if it is 0, so it will take, say, the first row. If it is 1, then it will take the first row, and it will convert it into float. It will try to find out a particular sample, and that particular a number. Okay, with that particular number p, it will be given to the multinomial function, and multinomial function will provide me an index. And based upon that particular index, say 14 is there, so on 14 what I'm able to see, n is the character or letter. So I will be able to see n. And once I of x is 0, once this particular index is 0, so it will stop. So because like the onto the 0 we are having dot, the ending character. So this has been mentioned over here. If I of x equal to 0, it means it will be stopped, because this is denoting the ending character. Okay, so I have iterated it with for loop. It will keep on going for each and every, you can say, row, and I will be able to get the name. Now, this was providing my one single name. So if I want to have the 15 names from the given, based upon the given input, okay, so I can calculate the 15 names as well. Just I have iterated with the for loop, and the range is 0 to 14. Like I will be having 15 outputs. So these particular names were generated. But there was an issue with this particular approach. Okay, the names are not looking like the names. So we need to do further optimization, and that's what we need to learn. That's what we need to see in this particular session. Okay, now one more thing that I want to explain. So so over here, uh, what I'm having, say this particular p is there. Let me try to copy p of 0. Okay, I have taken this particular, let me take the zeroth, you can say, row from the given tensor, and let me denote it with the with capital P at this moment, and let me try to print p. Okay, so p is this one. Okay, like 440013061542. This is nothing but onto the zeroth row. or first row, basically zeroth index and first row from a given tensor. You can take it in this way, like n is this one, n is the complete tensor what we are having, and this is of 20 cross cross 20 27 cross 27, we are having 27 rows and 27 columns, 0 1 2 3, we are having 27 rows. In the same fashion we are having 27 columns, okay. So we have taken the first row from this particular given, you can say, tensor, this is the first row. Now if I calculate this p equal to p divided by capital P equal to capital P divided by capital P dot sum, and it will provide me the percentage with respect to each and every element in a given row. Okay, so this is having 0 probability, this is having 13%, 4%, 4%, 5%, over here which one is having the most probability? 13 is the highest one, what I'm able to see. Thirteen is the highest one, huh? Okay, because this count is double for 10, and I think there is no any number which is having double for 10, count. That is perfectly fine, and in the same fashion, it has given me the outcome. And if I calculate like p of 0 and I calculate the sum of this, p of 0, this is nothing but dot sum. Okay, that is perfectly fine. What I want to explain, p dot sum, that is one perfectly fine, and p0, but it will be, it is coming 0. Just a minute, n of 0. Okay, so what I have done at this moment, uh, over here, what we have done, once we were having the small p, so we have taken an n of 0. Okay, we have taken the first row, and at that moment we have done the calculation, and we have done the calculation for the first row only. But guys, this complete calculation we need to perform for the complete tensor. On top of the complete tensor we need to perform this particular calculation now. Okay, so what I have done, I have assigned n to p. Okay, now p is this one. Okay, n dot float. So I have assigned this particular p n to p, and the p is this at this moment. P is having these particular values, n dot float. This is, you can say, n, this is n, and what I have done, I have assigned n to this particular p, and I have converted it into float. Okay, it is the values are coming in exponentials, no need to worry about that. What I want to explain, so the p dot sum, p dot sum, p equal to uh, p divided by p dot sum. Okay, so previously what we have done, we have done the calculation for the first row only. Now we are doing the calculation, this particular calculation for the entire all the rows, like we are having 27 rows, so it will be done for all the 27 rows, and p divided by p dot sum, let me remove this one, and at this moment p is this one. And if I find out uh, p dot sum, and that will come to 1, okay, that will come, that is perfectly fine now. Okay, so what I have done over here, say previously we were having, say, let's take an example, A S H O K. We are having, say, these particular values A S H O and K. Okay, so we were having certain counts, say 1 2 1, and say 2 1 1 1 1 0 9. Okay, 1 2 4 5, in this particular way, like say we are having these particular counts, you can take in this particular way. Okay, so previously we have taken this particular row, okay, and we have done the calculation, we have done the calculation, and for this particular row, like what we have done, we have taken all the elements and performed the sum of all the elements. Okay, p, and we performed the sum for all the elements. Okay, and it was looking like this, p equal to small p equal to p divided by p dot sum, okay, p dot sum. This was done with respect to the first row only, and we have calculated, say, 121 divided by, say, 850 is the total sum of 860 is the total sum for all these numbers. So 120 divided by 860, 21 divided by 860, okay, and triple one divided by 860, and 09 divided by 860, okay, and 125 divided by 860. This was done once we were having the small p, and the sum, the percentage for all these particular numbers were coming as 1, like if we have calculated p dot sum at that moment, so it was coming 1. that is perfectly fine because like we have moved with respect to this particular row only. But now once we are having the capital P, so we have not taken the single row, the complete tensor is taken, and this particular complete tensor, okay, onto the complete tensor we have performed the calculation. Now like it is with respect to all the rows, all the rows. And if we, that's what we are able to see over here, like the output what we are able to get, this is with respect to all the rows. And now if we calculate, if we find p dot sum, that is coming to 1. And if I calculate p dot p of 0, that is the first row, that is the first row, and if I calculate the sum for this particular row, it is coming 0.14. Like this particular row is having 14% contribution. This particular row, the first row, is having 14% contribution in the, in order to predict the next word. So this is having 14% contribution, what we are able to get with the help of this. Now what I need to do, what I need to do, so this is denoting the probability of each and every word, each and every letter, uh, each and every letter by giving a particular letter. Like if I'm providing a, S will be coming, so what will be the probability? So we are able to get the probability based upon the words, based upon the letters. But if we need to calculate the quality of this particular model, like how this particular model is behaving, so we are not able to get at this moment. Just have a look, let me try to do something. So we were having this particular for loop with while. So this was with respect to the single uh, row. Okay. Now what I will do, uh, each and everything is fine. So P. Okay. So P, instead of this n of ix, what I will do, P of ix. P of ix. I will pass. That is the same. Like it will be the same only. Like over here, P of 0. Like what is P of 0? That is n of 0. Like P is equal to n, and P of ix equal to n of ix. That is the same. So P of ix, that is, and why we have done this? Because like inside this particular for loop, like what we are having so many iterations, the calculation is happening over here only with respect to each and every iteration, and it is going to take more resources inside the for loop. The calculations are being happening. So what we have done, the calculations are have done outside this. And now uh, this is, this can be removed. P of ix, that is P of ix, that is this one. Okay, P of ix, that is like the calculation has been done already. So P is taken over here, and rest it will be the same only. And then perfectly fine. So we are able to uh, we have performed a little bit optimization over here. Now with this particular optimization, what I want to do, I just want to calculate the probability of each and every word, each and every letter. So let me try to how I will be able to calculate. So let me try to copy this particular code, what we have. Okay, let me copy this one. Okay, so I'm going to take say three letters, three words. I'm going to take three words, and starting and ending is denoted by dot over here. So that is perfectly fine. For ch1 and ch2 is jip in ch1. So over here we have taken the list that is starting from the zeroth index and first index, and then I of x equal to STOI of ch1, ix2 is STOI of ch2. That is perfectly fine. And what I need to do, I need to calculate the probability, and it will be P of capital P of ix and ix1 and ix2. I'm going to calculate the probability, and I just want to print it. I just want to print it, print, and say f ch1 and ch2, comma, what I want to have, probability, probability. Let me try to execute this. Syntax error, ch1. Okay. Okay. So let me try to make it more readable. Up to say 2f, 2 decimal points. I just want to have 2f or 4f. It is giving me in 4f. 4f. Let me take 4f. 2f. Percentage 2f. Okay. So over here, let me take 4f. Okay. So what I have done over here, I tried to calculate the probability of each and every iteration, each and every, like over here if I'm saying, say e is the most likely character after dot with respect to the m I'm talking, so its probability is 0.0067%, say near to 1%. Then e m is coming after e, its probability is less. M after m, it is having very less probability. Okay, the percentage is very less. Over here dot is coming after a, so it is having almost almost 3% probability or priority basically, or percentage, so that is having the highest count. In the same fashion, like this I after L, that is having almost 1% probability. 1%, the priority or probability you can take in any way. Okay, so we are able to get the priority or probability. Probability is not the correct word over here. because we are not calculating the probability, but I'm using in order to explain it so that you will be able to digest it properly. Yeah. So from the teaching perspective, I'm saying, so it is having the highest priority. Yeah. Now, what we have done, what we have done so far, with the help of this particular, you can say, for loop, we are able to see that this is given based upon the letters, like the priority of a particular letter after a given letter. But at this moment we are not having the information about the quality of this particular model. Let me write it down. Okay. So, how to summarize the this probability or priority? You can take priority in a single number that indicates the priority, the quality of this particular model. Okay, based upon given letters, I'm able to see that this will be the probability of next letter. Okay, but from the model perspective, we are not having the information. So how to do that? That we need to understand. Okay, so what I need to do, how I can do this? So if I take the product of all the numbers, okay, then I will be able to calculate the probability of the model. Uh, so the product of all the numbers, the product of all the numbers will be the probability or quality of model of this model, and if it is higher, then we can say model is working fine. Okay, okay, model is working fine. So but if we take the product, uh, but if we take the product that is very less number, very less number, we will see. If we take the product that is very less number, so what we will do, we will take the uh, log of this, that is log likelihood, and it is like, say, if I'm saying log of 1, that is what? Log of 1 is, log of 1 is 0. Okay, and if we go lower, and if we go lower, then log will be negative number, negative number up to infinity. Yeah. Okay, up to infinity. Okay, so over here we are trying to calculate the quality of model, and in order to do this, what we will do, we will take the log, because like if we do the product, then it is coming a very less number. So what we will do, we will try to take the log, and and after the like taking the log, then if the if this is lower, if we, and if we are going lower and lower, so it will go up to infinity. Okay, so because the log of 1 is 0, and if we are having, say, uh, if we grow negative, so the log of that will move towards the towards the infinity. Okay, so let's try to understand it with the help of this. So what we are having these particular numbers. Let me try to, so these are very less numbers. The priority, like if we do the product, so do the product of each and every number, each and every combination, then the outcome will be very less. So what I will do, I will take the log of this. Just have a look. That's what I try to mention over here. So this is the probability, and what I will do, log probability. Log probability, and it will be torch dot log of this particular probability. Okay, log of probability, and then I'm trying to print it. Just have a look, and probability, and I can have the log probability as well. Log probability. So I have taken the log of this particular output. Just have a look over here. So previously we were having the the less number, like the probability was very less, but at this moment what we are having somehow like higher number, and uh, higher number is there. Now if you are able to see, if these values are less than 1, then we are getting the outcome in negative. The all the values what we are able to get, uh, it is coming uh, in negative. So what I will do, what I will do, uh, I will take the negative of this, negative log likelihood. Just a minute. So what we are able to get, we are able to get the values in negative, and the highest it can get up to, the highest it can get is up to 0, to 0. Okay, so over here, like what we are able to see, like these are the negative values, and for this, what will be the higher value, like it is moving in negative. So negative, like it is, say if it is less, then it will be more negative. So what I can have, uh, what I can have, like if it is 0, then I will be having 1 as output. You can think in this particular way. So the model is having say 80% accuracy. Yeah, 80% accuracy. So 80% accuracy. That is say giving me 80% is denoted by 0.80, 0.80. So for this, what I will be having say minus 32. Okay, minus 32. This is the output what I minus 3.2. This is the outcome what I got after applying the log. Over here, what you are able to see, once I have applied the log on a particular number. Okay, so if it is, let me take 67347. Okay, so over here like 67 is there, 67 is having minus 5, and 07 point 0 point triple 07, it is having minus 7. So means if this percentage is decreasing, the values in negative are increasing. The uh, values in negative are increasing. So if this particular value is 1, then the output what it will be 0. Like if it is 100%, then the outcome what I will got, that is 0, because the log of 1 is 0. Log of 1 is 0. Over here it is mentioned, like log of 1 is 0. Okay, log of 1 is 0. So uh, if it is 0, if it is coming as 0, then I can say the model, this particular combination is performing good. It is having, you can say, 100% matching. It is having 100% matching. So the model performance, you need to pay attention over here. Like the log of 1 is 0, log of 1 is 0. That means the probability is 100% at this moment. Probability of 100, that is equal to 0. Okay, so we are getting the negative number. The the highest it can get up to 0, so it can get up to 0 only. Okay, 0 over here, 0. So it can be 1 over here, and in negative it can get up to 0, because like if this is 1, the output what it will be 0. If this is 1, the output what it will be 0. The highest it can get up to 0. That's when all the probability are, that's that is when all the probability all the probability are 1. Okay, that is perfectly fine. Then we want to have a loss function, and it should be that low is good. We will try to minimize the loss. Minimize the loss. Okay, so over here we are able to see that if it is towards 0, then what I can say, the model is performing good. The model is the this particular combination is performing good. Over here we have done the calculation for 5 words, but it will be done for 5 words only, or 3 words only, but it will be done for all the words. And if it is towards 0, then what I can say, the model is behaving good, and we need to keep it towards 0 only. Okay, so what we will do over here, we will invert this, we will invert this invert this. So -5 -7, -5 is good if we compare it with -7. -5 is good if we compare it with -7, and -3 is good if we compare it with -5. So more towards 0, the model is performing good. Okay, and if you want to have a loss function, it should be that low is good. Okay, so if it is towards the lower side, that means it is good, and we are trying to minimize the loss at this at that moment, we can say that. So we will invert this, and that will give us a negative log likelihood. Just have a look over here. Negative log likelihood. So I just copy this and paste it over here, and it will be log probability, or NLL, negative log likelihood, equal to minus of log likelihood. Log probability or log likelihood, both are same. And what I can have over here, I can have this negative log likelihood as well. NLL, and let me print this. Okay, so what we have done, like, just we have removed removed uh, this particular, you can say, minus sign. This particular minus sign. Okay, now what I will do, print, that is NLL Okay, so what we are able to see over here, that for this particular these three words what we have given. Okay, uh, so for these three words, like, the percentage of the model is, say, 3%. 3%, and if it is more, then the model will be behaving bad, and what we need to do, we need to move it towards the zero side. We need to move it towards the zero side. So that's what we are able to get with the help of this. So 3%, 3.5369 is the probability for this particular complete model. For these particular three, you can say, words what we are having. Just a minute. The negative log likelihood for this model. So we have calculated it for each and every one, and then finally we we are having it, and then we have printed it. Okay, so this is with respect to the complete model, like 5, 4, 3. Okay, no. This is not the correct one. 3569. This is not the correct one. Let me check on what has happened. So log probability and P of ix. That is perfectly fine. Okay, so we need to add something over here. Log likelihood equal to log likelihood plus log probability, and log probability is negative log likelihood. Hmm. I think it will be fine at this moment. What has happened? Log likelihood, we need to define it. Say it is 0. Something is not correct. Mm-mm-mm. Okay. Hmm. Just a minute. N of equal to 0. So NLL is this one, and okay. So what we have done, we have calculated the probability of each and every combination. Then we calculated the sum of all the combinations, and then we have divided the sum of these particular probability by the number of, you can say, iterations and all. Okay, so the n is the the value initially, like log likelihood is set to 0, n is also set to 0. And then what we have done, I just need to uh, keep increasing n as well. Okay, n equal to n plus 1 with respect to the iterations, it will be keep on increasing. And based upon this, like what I will be able to get, the probability, the negative log likelihood for this particular model is 5.1266%. So this is nothing but the quality of this particular model. This is, and over here, if it is towards the zero side, if it is towards the zero side, then we can say we will be able to optimize it. Okay, if it is towards the zero side. So over here, if we have applied the negative log likelihood onto this particular number, so it will be plus 5. Plus 5, that is, you can think like, say, if I'm having the probability of, you need to pay attention over here, guys. Probability was, say, 80%, 80%. And the log likelihood, it has given log likelihood, what it has given, it has given, say, minus 1.2. Then what we have done, negative log likelihood, what it has done, it has given 1.2. Okay, so this particular probability, we need to increase it. We need to increase it. Say if it is 0.90, that is the 90% of, or in another words, you can say this is, say, 80%. 80%. This is, say, 90%. Pay attention over here, guys. This is very important. 90%. So what will be the log likelihood? Say it is minus 0.5. I'm taking an example. Minus 0.5. Okay, it will be it will be more towards the zero side once we are performing the log likelihood. So, and once we take the negative log likelihood, it will be 0.5. Okay, 0.5. So what we need to do, we just need to move towards the zero side. And the, and what I can say, I will be having I will be having the good probability for a given combination. If, say, it is 1, so it will be, say, 0, and negative log likelihood, say, it will be, say, minus 0. What I can say. Okay, so we just need to move towards the zero side in order to improve the performance. So what we are able to get with the help of this particular example, the accuracy for this particular model, the model based upon these given three, you can say, words, is 0.51%. And we just need to improve it. We need to move towards the zero side for the improvement. And let's check the this with respect to all the words what we are having. And I just remove this printing. Okay, because like it will keep on iterating and we will be having lots of resource will be consumed over here. And let me run it. Okay, so it will give me the sum of all the combinations. This is the sum. And what we are able to see for the complete model, this is 5.2%, and for the three words it is 5.1%. So this is a little bit good with respect to this one what we are having. This is a little bit good stuff what we are having. Now what we need to do, okay, so over here it might be possible this particular value can come in infinity. Like say if a particular combination is not available, uh, but let me try to show with an example. Let me try to mention a particular word. Uh, if W is there in word, say I'm having a particular word over here and I'm providing a word. Let me print this as well. Okay, so over here in the given in this particular given, you can say sheet, in the given names J after Q. Okay, J after Q after J, it is coming 0 times. J over here, just have a look. Uh, Let me J after Q. What is the Q after J? Q after J. So I just need to take J and Q. Okay, so just have a look over here. Let me try to increase it. Why I am showing so? Okay, so this is the K row. Okay, and over here even G is also like G is on, also not coming after. I was JQ, JQ. J JQ. Okay, so this is the J row, and over here what we are able to see, Q is coming 0 times after J. Okay, so if a particular combination is there, over here what I have given a name, and if there are certain names which are having zero counter, because like this particular percentage it is giving based upon uh, the the you can say calculation what we have done, based upon the probability calculation what we have done. So over here with this particular and raise Q, the name what is available over here, the Q is not coming after J in our names.txt. Okay, we are not having a single combination where Q is coming after J. So for this the count will be 0 and the outcome what it will be, the infinity. So then the something is added to infinity, then the outcome will be infinity. So the model will not give the correct outcome at this moment. The model is not giving, we will not be able to calculate the quality of this particular model. So in this particular case guys, what I need to do, I need to add a uh, you can say random number, or add a particular number in each and every combination. So and then like what I will do, I will perform the calculation and then I will be able to get the output. Just have a look over here. So what I will do, say if I'm having uh, p and it is equal to n, and say I will perform the addition of a particular random number and then convert it into float, the same thing. So if this is there and let me try to copy p equal to p dot sum, and I can do say 1 and keep dim equal to true, keep dimension true. The now this particular 10,000 number will be added in each and every element. Okay, and I will be able to get this particular outcome, say, yeah. Now what I will do, I will perform the execution once again for this particular given piece of code, and what I am able to, I will be able to see, like say at this moment JQ, it is having this particular, you can say, outcome, and the model is having a little bit, you can say, more good performance as well. Okay, so over here what I have done, I have added a random number, a particular number in the given tensor. It will be added to each and every element, and at this moment, like the model, so previously the count was say 0, n was 0, and at this moment n will be having certain values. Okay, so over here n will be having certain values. This is n, I just need to print p basically. P, or you can say, you can take it in this particular way. Let me try to mention. So if I'm adding something in say n equal to n plus 1000 plus float, that will be converted to float, and if I'm printing n, so what it will be, just have a look over here. No, any number will be zero over here. Okay, it will be having certain count. So if the there is certain values in a given combination, then definitely it will never come to, it will never go to infinity. Previously it has gone to infinity because the the outcome over here was 0, the sum was 0, and if we are taking the log of 0, so it goes to infinity, and because of that, like the output was infinity. So in order to optimize it, what we have done, we have added a number into n, and post addition of the number, what we are able to get, the model is a little bit optimized, a little bit optimized, and we are able to get the outcome. It is not going inside the infinity. Okay, so that is the stuff. Now what I can do, okay, I think that's it for this particular session. Let me explain what we have done. So so we were having these particular steps, we have executed these particular steps, and we iterated with while loop, and then we were able to predict. So over here, after predicting, the output was coming, but it was not in meaningful way. meaningful way. Okay, it was not meaningful, huh? It was not meaningful. So we need to optimize it, huh? We need to optimize it. Okay, so that we will see, we need to optimize it. Second issue what was there, we were we were not able to calculate the probability of complete model, huh? Complete model, huh? We were not able to calculate the probability of complete model, huh? So for this what we have done, we have calculated the log of we have calculated the probability of, okay, over here we are able to calculate the probability of each combination, but we are not able to calculate the probability of the complete model, huh? That is perfectly fine. So for this what we have done, uh, we have calculated the log. So for this, in order to calculate calculate the probability of complete model, we need to perform the product, but it will be very less number. So what we have done, we have taken the log, and then we have taken the negative of log, that is nothing but negative log likelihood, NLL. Let me mention negative log likelihood, NLL. Okay, we have taken the log and taken the negative of log and divide sum of all probability by count. So we are able to see model probability, we are able to see model probability, but there is a challenge, but there is a challenge. If a combination is having zero count, then output was coming as infinity, infinity. We have seen this, like, say, q is having zero count after a after j. Okay, so q is not likely to come after j. Okay, so the model has given probability as infinity over here. So how we have optimized this? We added a number in given tensor with all the elements, all the elements. Then the count will never become 0, and we will be able to avoid infinity like situation. Okay, infinity like situation. So that's what we have done in our today's session. So we were having certain, we were having the probability of each and every combination. So in order to get the probability for the complete model, what we have done, we have taken the log likelihood. Okay, log likelihood was giving the negative number. Okay, so in order to make it you can say positive number, we have taken the negative of this, that is negative log likelihood. And based upon that, what we are able to see, like the sum of all the tensor is 82.02%, and 02, and the negative log likelihood for, over here is 5.12%. Okay, so we are able to see this particular stuff. Then we have seen it with respect to all the words given in names.txt. We have gone through with a particular situation, like if a particular name is there, and whose combination, it might be possible, like there are certain names and all, okay, whose combination is you can say 0 with respect to the given names.txt, and in that particular situation the outcome will come as infinity. So we have avoided this particular situation by adding a number in the given, you can say, in the given tensor. And once we have added this particular number, it becomes a new, you can say, tensor. And the this particular situation which was there, it was avoided, and now we are able to get the outcome as well. Okay, so this is the stuff, guys, that we have done. Now moving further, what we will see over here, we have done it mathematically. Then we will try to perform the same stuff with, you can say, with deep learning, with deep learning library. Okay, over here most of the stuff is by maths only. Okay, now we will be using the deep learning libraries to perform this, and then we will be going through with the MLP, multi-layer perceptron example. Okay, based upon this only. Okay, so then we will be having the clarity how this particular the transformers are working. Then we will start our you can say learnings uh, with RAG. Okay, and then we will be having a project onto the Databricks on RAG. So this particular project will be there onto Databricks. We will be, let me try to show. Okay, so we will be going through with this particular project in RAG. Okay, so this is also from the Databricks side. We will be reading the file PDF files, and then we will load into the Databricks cluster. Okay, we will create vectors and all. This is particular project is, you can say, to create a chatbot related stuff. Like say over here the example was given for the washer manual. Okay, so if a particular washing machine is having certain issues, then how you will be able uh, to chat, how a user will be able to chat with the model, and the model will provide the outcome that this is the issue with your washing machine. Okay, so that particular stuff is there. Although like the diagram seems complicated at this moment, but once we will be moving with the practical and all, this will be very simple. So what I can recommend at this moment, you need to go through with the code and the basics. Try to understand the logics, what is being happening. Okay, and try to do it by yourself. I have shared the code and all. I have shared the notepad file as well. So try to read it, try to go through with this, and then do it by yourself, and you will be having the base. Then we will be going through with data bricks and the lang generated stuff what we are having in our upcoming learning journey. So it will be good if you do the practice. So try to spare 1 or 2 hours on daily basis for the practice only, and that will be good for your learning journey. So that's it for this particular session, guys. If you are having something in your mind, then you can ask. Swati, Raj, Vijay, Gaurav. Okay, if nothing is there, then we can conclude the session now. Thank you.
Thank you, sir.
Thank you.